So basically what we're doing with this next video for 3-6 is testing out to see whether the multiplicative properties, the ones that work for, normal numbers and stuff, to see whether they work for matrices as well. So if you look at this one, we've got K and L, and we're trying to find K times L as well as L times K. So what we're testing here is the commutative property to see if multiplying them in a different order would make a difference. Okay, so first, when we're setting up multiplication, we want to set up the dimensions. So this one has 2 rows and 3 columns. And this one has 3 rows and 2 columns. Okay, so K times L. K times L would be a 2 by 3 times a 3 by 2. So the middle dimensions match up, which means that we're able to multiply them and we'll get a 2 by 2 as a result. Okay, so we're going to get everything all set up to multiply out together, and we know we're going to get a 2 by 2, so 2 rows, 2 columns. Okay, so we always do rows for the matrix on the left and columns for the matrix on the right. So for row 1, column 1, we are lining up row 1 here with column 1 here, and remember we multiply each entry together and then add them together. So negative 3 times positive 1 gives me negative 3, plus 2 times 4 gives me 6, plus 2 times 0 gives me 0. Okay, then I move over here. I am still in row 1, but now I am in column 2. So I still use row 1 over here, but then I am going to pair it up with column 2 this time. So I pair up negative 3 times negative 2, that gives me 6. 2 times 3 also gives me 6. 2 times negative 1 gives me negative 2. Okay, move down to the next row. Now I'm in row 2. I'm back in column 1. So I'm going to use row 2 right here times column 1, match them up and multiply them. Negative 1 times positive 1 is negative 1. Negative 2 times positive 4 is negative 8. 0 times 0 is 0. Then I move to my last spot. This is row 2. Now I'm back in column 2. So I'm going to use row 2 here in K and column 2 here in L. Negative 1 times negative 2 is positive 2. Negative 2 times positive 3 is negative 6. And 0 times negative 1 is 0. Okay, so I'm going to clean all this up. Negative 3 plus positive 6 plus 0 gives me a positive 3. Next column, 6 and 6 is 12. Negative 2 goes back to 10. Negative 1, negative 8 is negative 9. Positive 2, negative 6 is negative 4. So that is the matrix that I get for K times L. All right, so now let's do L times K. So I'm going to rewrite these just so you can see them going by rows and columns since they're going to switch. So here's L. Remember, now that we're putting L first, we're going to organize L by rows instead of by columns. So I'm just going to rewrite them. Okay, and then here is L times K. So here's L, we're going to organize it in rows, and here's K, we're going to organize it in columns. So just so we know what we're expecting, L is a 3 by 2, K is a 2 by 3, so we're allowed to multiply them together since their middle dimensions match up, and the new matrix that we get is going to be a 3 by 3. Okay, so LK is going to be a 3 by 3 matrix, so we can set that up. So before we even finish this problem, I think you can see that KL and LK are not the same. We're going to go through just so we can get some multiplying practice, but a 2 by 2 matrix couldn't possibly end up the same as a 3 by 3 matrix. Let's set all this up though. So 3 by 3, we are going to have 3 rows, 3 columns. Okay, so this one is a bigger problem than we've dealt with. So here we have row 1, column 1. This is 1, 2, 1, 3. Then we move down to row 2. So this is row 2, column 1, 2, 2, 2, 3. And then finally we're in row 3, column 1, 3, 2, 3, 3. So row 1, column 1, we're going to use row 1 here, column 1 here, add them up from the products. So 1 times negative 3 Add that to negative 2 times negative 1. Next, row 1, column 2. 1 times 2, negative 2 times negative 2. Okay, and then to finish off this row, we're still in row 1. We're moving to column 3 for this position. 1 times 2 is 2, plus negative 2 times 0 is 0. All right, so that's the end of row 1. Now we move down to row 2 and then go across the columns. So 2, 1, we use row 2, column 1. 4 times negative 3 is negative 12, plus 3 times negative 1 is negative 3. Row 2, column 2, 4 times 2 is 8. 3 times negative 2 is negative 6. Row 2, column 3, 4 times 2 is 8. 3 times 0 is 0. Okay, last row. We're in the third row here, and again, we're going to move across the columns. So 0 times negative 3 is 0. Negative 1 times negative 1 is positive 1. Row 3, column 2, 0 times 2 is 0. Negative 1 times negative 2 is positive 2. And finally, 3, 3. 0 times 2 is 0. Negative 1 times 0 is 0. Okay, so to get our new matrix, we're going to add all these things together. Negative 3 plus 2 is negative 1. 2 plus 4, 2 plus 0. Negative 12 plus negative 3, 8 and negative 6, 8 and 0, 0 and 1, 0 and 2, 0 and 0. So that is my 3 by 3 matrix. So in case we can't tell, we are going to make ourselves a little note that says that multiplicative commutativity does not hold. So these are some big fancy words here. That just means if you multiplied two things in a different order, they're not necessarily going to come out the same. Now there may be exceptions, but as a rule in general, commutativity for multiplication does not hold. We just learned that. Okay, so now with example 5, what we're going to be testing out is the distributive property. Like if we distribute this A to both of these matrices, are we going to get the same answer or not? So when we are testing this one, order of operations holds, so we're going to add B plus C first. So these are all 2 by 2 matrices. That means we're allowed to add them and multiply them. So add B plus C means we're going to add the corresponding entries. So we add 1 plus negative 3, and we get negative 2. Add 0 plus 1. Okay, down here, 3 plus negative 1. And negative 2 plus 0. Okay, so that is B plus C. Now, to get A times B plus C, we are going to line these up like multiplication. So first A, so negative 1, 2, 2, 1, and then times what we just got, B plus C. Okay, so we're going to multiply these two matrices together. Again, they are both 2 by 2s, which means I'm allowed to multiply them. These middle match, and so the outside will be my new dimension. So I know my new dimension is going to be a 2 by 2. Okay, so let's label all these. This is row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. Okay, so here's what I'm multiplying over here. So row 1, column 1, row 1, column 1. Negative 1 times negative 2 is positive 2. 2 times 2 is 4. Okay, next, row 1, column 2. Negative 1 times 1 is negative 1. 2 times negative 2 is negative 4. Bottom left, we've got row 2 back to column 1. 2 times negative 2 is negative 4, plus 1 times 2 is 2. And row 2, column 2. 2 times 1 is 2. 1 times negative 2 is negative 2. Okay, so I'm going to combine these up. 2 and 4 gives me 6. Negative 1, negative 4. Negative 4 and positive 2. And positive 2 and negative 2. So that is what I get if I add inside the parentheses first, then multiply by the A. Okay, let's see what we get if we multiply first, then add together. So let's start with A times B. So here's A, and I want to multiply it by B. Okay, so we've done enough of this matrix multiplication. I think we can do it fairly quickly. So this first spot is going to be the first row, first column. So I can use first row, first column. So -1 times +1, 2 times 3. Okay, now I'm going to move over to the first row, second column. So I use first row, second column. -1 times 0, 2 times -2. Okay, now I move down here. I'm in the second row, first column. So 2 times 1, 1 times 3. And then finally, second row, second column. So 2 times 0, 1 times -2. Okay, so let's clean this up. Get our first matrix, AB. -1 and +6, 0 and -4, 2 and 3, and 0 and -2. Okay, so that's AB. Now let's get AC. Okay, so again, here's A. And I will copy down C, -3, 1, -1, 0. Okay, so again, I know I'm going to get a 2 by 2 matrix, and we can go through this fairly quickly. So this first spot is row 1, column 1. So -1 times -3, 2 times -1. Next, row 1, column 2. -1 times +1, 2 times 0. And down here, row 2, column 1, 2 times -3, 1 times -1. And row 2, column 2, 2 times 1, 1 times 0. Okay, so combine these up. Add each item together. 3 and 3 minus 2, -1 and 0, -6 and -1, and 2 and 0. Okay, so this is AB right here. This is AC right here. Now we want AB plus AC. So we're going to take the two pieces we got, add the corresponding elements together. Okay, so 5 and 1 gives us 6 in the first row, first column. -4 and -1 gives us -5 in the first row, second column. Down here, 5 and -7 leaves me with -2. And finally, -2 and +2 leaves me with 0. So I end up with the exact same thing for both of these. So the distributive property does hold. Okay, so we've got one property that does hold, one property does not. We've got one last problem. Actually, I'm sorry, we don't have one last problem. We just have the properties that we're going to write down. So the ones that we just mentioned, we've got the commutative property, we've got the distributive property. I'm just going to write down a summary here. So here's what else we have. We've got the associative property that also holds. So the associative property looks like this. So we did not prove that one, but you could if you want to. And then we have the left distributive property, which is what we just proved. And then we actually also have the right distributive property, which would look like this. Because remember, left and right multiplication are different since the commutative property doesn't hold. But right distribution holds just as much as left distribution. So we've got those three properties.